Yeah, good evening, children. Good evening, Srijit and Sahasra.
Evening, ma'am.
Good evening. Yeah. Identify the rational numbers and irrational numbers. First one, root 7. Root 7, irrational. Root 16. Because what's the value of square root of 16? 4. So it is rational. 4 is 4 by 1, right? P by Q form. So rational number. See, 1.625. 1.625 is a rational number because it's a terminating decimal. Terminating decimals are rational numbers. Non-terminating, repeating decimals are also rational numbers. Terminating decimals and non-terminating, repeating decimals are rational numbers because both of them have a P by Q form. Okay, so 1.625 is a terminating decimal. It has a P by Q form and hence it's a rational number. Correct. So D is a non-terminating decimal because you can see the dots here. It's a non-terminating decimal. D is a non-terminating decimal, but non-terminating decimals are of two types. Non-terminating, repeating, non-terminating, non-repeating. So we have to, understand if this is the non-terminating, repeating or non-terminating, non-repeating. See, it's non-terminating because it goes on and on. You can see the dots here. It goes on forever. So it is non-terminating. And it's also repeating because this digit 3 is going on forever. This number is nothing but 5.2483 recurring. So there is this digit 3 which repeats forever. So it is a non-terminating repeating decimal and hence a rational number. Terminating decimals and non-terminating repeating decimals are rational numbers because they have a P by Q form. Okay. Okay, so D is 5.2483 recurring, non-terminating, repeating. So it's a rational number. What about E? Okay, see, can you see this? In the last class, 62.425 recurring. See this question. Last class we did this, 62.425 recurring. What kind of a decimal is this? Non-terminating, repeating, right? And see, it has a P by Q form. This one is a non-terminating, repeating decimal, right? Look at this, 62.425 goes on forever. It's a non-terminating, repeating decimal. And see, we've derived its P by Q form. E is because it's non-terminating. It's non-terminating. It's non-terminating because you can see it's going on forever. The dots tell us that it's going on forever, non-terminating. Is it repeating or non-repeating? You'll have to watch that carefully. Do you find a digit or a set of digits repeating themselves? Do you find a digit, a single digit, or a set of digits repeating themselves? 5426973154021. No, you can see that the digit, you can see this 5, it repeats. After 5 here, you can see 5 repeats here. But here it is 54269. Here it is 54021. No. See this digit 5, repeat 5, 4, 2, 6, 9, 7, 3, 1, and then again this digit 5 repeats. But you can see what follows that 4, 0, 2, 1. It's not the same as this one. So the dots say that it's non-terminating and it's non-repeating because we don't find a pattern in the decimal part. There is no digit or a set of digits repeating themselves. So it's non-terminating, non-repeating. Hence, it's irrational. This kind of a decimal is irrational. The last one is 20.2200, 2200, 22200, 4 twos, 4 zeros, 5 twos, 5 zeros. No. That's not a pattern. The pattern should be like the pattern repeats itself. Yeah, right. So if that was a pattern, it should be 2 twos, 2 zeros. Again 2 twos, 2 zeros. Again 2 twos, 2 zeros. Here it is different. Here it is 2 twos, 2 zeros. Then 3 twos, 3 zeros. 4 twos, 4 zeros. No. So you don't see a digit or a set of digits repeating themselves. The same thing should repeat. Now that pattern we don't see here. But it's non-terminating because it's going on forever. It's non-terminating and non-repeating. Non-terminating, non-repeating decimals are irrational numbers. F is non-terminating, non-repeating. And hence it's an irrational number. If it's a terminating decimal, a rational number. Non-terminating, repeating decimal, rational number. Because both of these decimals have a P by Q form. The third one, non-terminating, non-repeating decimals. They don't have a P by Q form. And hence they are irrational numbers. Yeah, right on. Yeah, write the question. Take the question, write the answer.
Let me just make example one. What about here? The long digit should be or no, ma'am, the digits are too long, or only like 32 or
Write what I'm writing here. Hence a rational number. Please write that number. Okay, I'll just write half of it. Complete that number, okay? Complete the number 8.5426. Complete that number. Okay. F, same answer as E. Don't write same as E, write the same answer. That number is a non-terminating, non-repeating decimal and hence an irrational number. Completed?
Yes, ma'am.
Okay. For F, you should not write same as E. You must write that number and say is a non-terminating, non-repeating decimal and hence same answer you should write. Don't write same as E. Yeah. Same answer. Yeah, correct. Completed? Yeah.
Ma'am, writing the E one.
Okay. Completed, Srijit and Sahasra?
Yes, ma'am.
Okay. Okay. Write any three examples each of rational and irrational numbers. Okay. Is this a rational number? Is this example? Is this expression an example of a rational number? Look at the square root symbol. Very good. Yeah. So what's the answer? When you simplify, what do you get? 7 by 11. 7 by 11. Square root of 49 by 121. Just because there is the, yeah, just because this is called the radical sign. This one, this is called the radical sign. Radical sign. Okay. It's a new term. So this square root of, cube root of, fourth root of, fifth root of, all these are called radical signs. Okay. Square root of, cube root of, fourth root of, fifth root of, 10th root of. This sign is called the radical sign. Okay, just because you see the radical sign, normally an irrational number carries a radical sign. Normally, there are examples of irrational numbers which have a radical sign, like we just saw here. Square root of 7, square root of 7. See this radical sign? Square root of 7. The square root of 7 is a non-terminating, non-repeating decimal. So we have learned in the chapter squares and square roots how to find. Are you listening to me, Avanish? Okay, in the chapter squares and square roots, we have learned how to find the square root of a number by the long division method, right? Up to 2 decimal places, 3 decimal places. Why up to 2 decimal places, 3 decimal places? Because the value goes on forever. So they ask you, because so you cannot find the, there is no exact answer or complete answer. It goes on forever. The value of root 7 goes on. It's a non-terminating, non-repeating decimal. That is why in the question it's mentioned, find the value of square root of 7, correct to 2 decimal place, correct to 3 decimal place. Okay. So square root of 7, the value of square root of 7 is a non-terminating, non-repeating decimal. It's an irrational number. So irrational numbers normally, there are examples of irrational numbers that carry a radical sign like this. But just because you see a radical sign, that doesn't mean it's an irrational number. So what is the square root of 49? 7. Square root of 121? 11. Integer by integer. 7 is an integer, 11 is an integer. Integer by integer is a rational number. So this is an example of a rational number. Now, what about cube root of
8. Cube root of 8.
what about cube root of 1331? It's 11. 11 into 11 into 11. 11 into 11 into 11 is 1331. So cube root of 1331. So this is the radical sign. This cube root is the radical sign. Just because we see the radical sign, that doesn't make it an irrational number. The value of cube root of 1331 is 11. And 11 is 11 by 1. Integer by integer. 11 is an integer. The value is 11. And 11 is 11 by 1. Integer by integer. Rational number. P by Q form, rational number. Okay? Yeah. Yeah.
Can you just write a number like 75 by 2, 79 by 2?
Yeah.
You can write any numbers fraction like anything you want.
Yeah. Okay, you can write a terminating decimal, say like 3.17215. That's all. Rational number. Or you can write, say like 13.17575. 1 second. You can just put the dots. You can put the dots like this, or you can write 13.175 recurring. So what is this example? What is example 5? Example 5 is a non-terminating repeating decimal, rational number. Example 4 is a terminating decimal, rational number. 3, P by Q form, integer by integer, rational number. Cube root of 1331 is 11, 11 by 1, rational number, P by Q form. And the first one, 7 by 11, rational number. Okay, because this also is 11. I'll just change this one. I'll just change this to 169. What's the square root of 169? 13. Okay, so 7 by 13. Because here also it's 11. I just changed that. Yeah, take down. 3 is enough, but I've written 5. Write all the 5. Write all the 5. No, see, they're asking you to give examples. You should not simplify. Give examples. So just write the example and leave it. Don't simplify. square root of 10. Is there any number which when multiplied by itself, I'll give you 10. A number into itself should give you 10.
No.
Can you tell me a number like that? Should give you exactly 10. A number multiplied by itself, not 2 5s are 10. A number multiplied by itself should give you exactly 10. There is no such number. Hence, square root of 10 is an irrational number. Now, if I say cube root of 27, yeah, there is this number 3, which when multiplied by itself 3 times will give you 27. So the cube root of 27 is 3. But if I write cube root of 30, there is no number when multiplied with itself 3 times will produce 30 as the product. So cube root of 30 is an irrational number. You can write a non-terminating, non-repeating decimal as an example. Yeah, so 7.1011011110 goes on like forever. 11110.
Can we write our own example?
Yeah, please. Take down mine and then you can give more of yours. Also include my examples. Square root of 2. Look at the fifth example I've written. Square root of 2. No number into itself will give you 2. So it's a non-terminating, non-repeating decimal. That one by 7, when you divide the value of root 2, which is a non-terminating, non-repeating decimal, by 7, that will be another non-terminating, non-repeating decimal. Correct. So since root 2 is a non-terminating, non-repeating decimal, when you divide that by 7, that quotient also will be some new non-terminating, non-repeating decimal. Yes. You can even write, say like root 5 plus 2 or root 5 plus 4. Square root of 5 is irrational. Plus 4. What is square root of 5? It's a non-terminating, non-repeating decimal. And if you add 4 to that, you'll get a new non-terminating, non-repeating decimal. So square root of 5 plus 4 is an irrational number. Yes, square root of 16 plus 4 is a rational number. No, no pattern means no, it's not rational. Yeah. One digit or a set of digits should repeat. Completed?
Yes, ma'am.
Okay. Okay, look at this fact. Actually, look at this fact. Rational numbers where the denominators are powers of only 2, 5 or both are terminating. I'll give you examples to understand this. Now, supposing we have this number 7 by 8. 7 by 8. Listen carefully. Everything new will sound difficult. Everything new will sound difficult. Some concepts are very easy to understand. You grasp it immediately. Some concepts, even after the teacher explains, you feel like as if no, I don't understand. I meaning I can't really get it. That happens. You need to repeat. If you go through the content again at home, you will be able to get it. So with more repetition, you will be able to retain it. When you hear it for the first time, it will sound like so difficult. That's normal, that's natural, that's normal. Some concepts are very easy to understand. Listen to this very carefully. 7 by 8, integer by integer, rational number. Okay. Is it in the simplest form, 7 by 8? It is in the simplest form. You cannot simplify any further, no? See, when I ask you, is it in the simplest form? Now, for example, 10 by 35.
No.
This is not in the simplest form. Yeah. Now 10 by 15 is integer by integer. It's a rational number, but it's not in the simplest form because 5 2s are 5 7s are 2 by 7. 2 by 7 is the simplest form of 10 by 35. In the same way, 7 by 8. Can you reduce this any further? No, then that's the simplest form. Okay, that is the next step. So 7 by 8 is a rational number. Agree? In the simplest form. 7 by 8 is in the simplest form. Yes? Okay. Now look at the denominator. What's the denominator? 8. Okay. Now can you write 8 as 2 to the power 3? Yeah. So what are the factors of 8? 8 is 2 into 2 into 2. 2 to the power 3. You can see, so the denominator has only one prime factor, 2. It happens 3 times. How many times that prime factor happens is okay. That's not, meaning you don't have to really worry about that. What you need to see is what is the prime factor or what are the prime factors of the denominator. So the prime factor here of the denominator is 2. 2 into 2 into 2, but 2. 2 is the prime factor. Then 7 by 8 has a terminating decimal expansion. Okay, so 7 by 8 has a terminating decimal expansion. It is 0.875. 7 by 8 is 0.875. See, what are we doing here? When you look at the rational number, you can say if it has a terminating decimal or not. When you look at a rational number, what are the two types of a rational number? Terminating decimals, non-terminating, repeating decimals. Rational numbers have two types of decimal expansions. Rational numbers have two types of decimal expansions. Terminating decimal or non-terminating, repeating decimal. Now, 7 by 8 is a rational number. Yes. And it is in the simplest form. Yes. Look at the denominator. What is it? 8. And how do you express 8? 2 into 2 into 2. 2 to the power 3. In the exponential form, it is 2 to the power 3. So what is the prime factor of 8? 2. Only 2, right? There's no other prime. Only 2. Then 7 by 8 has a terminating decimal expansion, which is 0.875. Now you'll wonder, how will you get this? When you divide 7 by 8, the answer here will be 0.875. Now take this example, 4 by 125. 4 by 125. Okay, yeah, correct. This is the next example, 4 by 125. Is it in the simplest form? It is a rational number because integer by integer, so it's a rational number. Is it in the simplest form?
Yes.
It is in the simplest form. You cannot simplify any further. You cannot cancel it and reduce it any further. So it is in the simplest form. Next, Look at the denominator. Yeah, I looked at the denominator. What is it? 125. How do you write 125 as a product of its prime factors? 5 into 5 into 5 or 5 to the power 3. 5 into 5 into 5 or 5 to the power 3. So what is the prime factor of the denominator? 5. Only 5, no? Then this one also has a terminating decimal expansion. See, 4 divided by 125 is 0.032. When you divide 4 by 125, the quotient is 0.032. One more example. Consider 11 by 40. 11 by 40. Okay. 11 by 40. Is it in the simplest form? It is in the simplest form. Okay. Now, express 40 as a product of its prime factors. So it is 2 cubed into 5. You should find this one, this method. Okay, you will get 2 cubed into 5. Okay, I'll do it for you. 40. 2, 20 times 2, 10 times 2, 5 are, 5 ones are, correct? So you can see 2 cubed into 5. 2 cubed into 5. So what are the prime factors of the denominator? 2, 5. 2, 5. So here the prime factor was 2. Here 5, here both 2 and 5. In all these cases, the rational numbers will have a terminating decimal expansion. The prime factorization of the prime factor of the denominator can be 2 or 5 or both 2 and 5. How many 2s, how many 5s, that is not, that you don't have to really consider. The prime factor or factors of the denominator should be 2, 5 or both 2 and 5. Then that P by Q will have a terminating decimal expansion. So now when you divide 11 by 40, 0.275. Finished. When you divide 11 by 40, the quotient is 0.275 and the remainder will be 0. Okay, so we considered the rational numbers 7 by 8, 4 by 125 and 11 by 40. We'll see it again. Okay. Okay. 7 by 8 is in the simplest form. You cannot simplify that any further. Denominator is 8. Okay, denominator is 8. It's 2 into 2 into 2 or 2 cubed. The prime factor of the denominator 8 is only 2. Then 7 by 8 has a terminating decimal expansion. That is when you divide 7 by 8, the quotient is a terminating decimal and the remainder will be 0. Because terminating decimal division will come to an end. 0 remainder. 4 by 125. 4 by 5 cubed. 4 by 5 cubed. See, 4 by 125 is a rational number and it is in the simplest form. Denominator is 125. Prime factorization 5 into 5 into 5 or 5 cubed. The prime factor of the denominator is 5. Terminating decimal expansion. 4 by 125 has a terminating decimal expansion. That is when you divide terminating decimal, remainder will be 0. When you divide 4 by 125, the quotient is a terminating decimal, the remainder is 0. Similarly, 11 by 40, simplest form. Prime factorization of the denominator, 2 cubed into 5. 2 cubed into 5. So the prime factors of the denominator are 2 and 5. 2 and 5, nothing other than 2 and 5. So when you divide 11 by 40, the quotient will be a terminating decimal and the remainder will be 0. So if the rational number in the simplest form, okay, let me put it like this. if the prime factors of a rational number, which is in the simplest form. You're distracting me, Navneet. I'm talking and you're doing something there. Oh, I forgot what I was telling you. Rational number, simplest form, denominator, prime factors. Rational number, simplest form, denominator, prime factors. 2 or 5 or both 2 and 5, but nothing other than this. Such rational numbers will have a terminating decimal expansion. That means when you divide the numerator by the denominator, the division will come to an end with a zero remainder and the quotient will be a terminating decimal. Rational number, simplest form, denominator, prime factors, 2 or 5 or both 2 and 5. How many ever times? 2 or 5 or both 2 and 5. No other prime factor should be there. No 3, no 7, no 11, no 13, no nothing. 2, 5 or both 2 and 5. Such P by Qs. In such cases, when you divide P by Q, when you divide the numerator by the denominator, the division will come to an end with a zero remainder and the quotient will be a terminating decimal. Take down. Very important fact. If there is now, see, if there is some other prime happening. Now look at this example. 1 minute, let me complete this. Now look at this example by 75. So 7 by, this will be 5 squared into 3. There is 5, but this 3 should not be there. 3 is other than 2 or 5. Then this one will have a non-terminating repeating decimal expansion. It will not have a terminating decimal expansion. It will have a non-terminating repeating decimal expansion. It cannot have a non-terminating, non-repeating decimal expansion because that is an irrational number that does not have a P by Q form. Yeah, correct. So 7 by 75 is in the simplest form. Denominator, prime factorization, 5 square into 3. There is the prime factor 5, but there is also 3 with it. No, this P by Q will have a non-terminating repeating decimal expansion. Yeah, you should take as I've written here. Yeah. So when you divide 7 by 75, the division will not come to an end. It will keep going on forever. And the quotient also will go on forever because it's non-terminating. But it will be a repeating decimal. In this case, in this case, the digit 3 will go on forever in the quotient. So it's a rational number. Louder. Oh, you want the decimal? Okay. You want this one, huh? Oh, okay. Okay, yeah. Right? Yeah. Completed? Online children?
Yes.
Yes. Okay. Srijit, you have a question to ask?
No, ma'am.
Okay. Okay. Now talking about pi and 22 by 7. Okay. Pi and 22 by 7. 22 by 7 is a rational number because it is in the integer by integer form. 22 is an integer. One second, online children. Okay, so 22 by 7 children. 22 by 7 is integer by integer. 22 is an integer, 7 is an integer. And this is how we remember, no? Integer by integer is a rational number. So 22 by 7 is a rational number. But you all know the area of a circle is given by the formula pi r square units. Area of a circle is given by the formula pi r square units. And there, when you find the area of the square, for pi, you take this value 22 by 7, right? Pi is 22 by 7 into whatever is the radius given, suppose 7 into 7. So we take the value of pi as 22 by 7. But pi, the value of pi is not 22 by 7. Pi is a non-terminating, non-repeating decimal. The value of pi is a non-terminating, non-repeating decimal. Now, what is this pi? Okay, let's understand what is this pi. Okay. Okay, so if you know this formula, circumference of a circle, 2 pi r. Circumference of a circle is given by the formula 2 pi r, or circumference of a circle is given by the formula pi d. So what is pi? Pi is equal to c by d. So pi is the ratio of the circumference of a circle to its diameter. The ratio of the length of the circle to the diameter of the circle is the value of pi. And it's observed that when you divide the circle, when you find the length of the circle using a thread, Okay, you can find the length of the circle, right, using a thread. So when you find the length of the circle and divide by the diameter, the value is a non-terminating, non-repeating decimal. Pi is the ratio of the circumference of the circle to its diameter, which is a non-terminating, non-repeating decimal. Pi is the ratio of the circumference of the circle to its diameter. That's why this formula, circumference is equal to pi d. Circumference is equal to pi d. That means pi d is equal to circumference. So pi is equal to circumference by d. This is a big topic to discuss, so I'm just telling you in short. So just understand that pi is the ratio of the circumference of the circle to its diameter. And this is a non-terminating, non-repeating decimal, the value of pi. So pi is an irrational number. Pi, you can just make a note of this. I'll finish it and then you write. Before you take this question, write this note, okay? Not now, just wait. 22/7 is a rational number. Pi is an irrational number because it has a non-terminating non-repeating decimal expansion. What are you doing, Navneet? What are you doing? Answer my question. What were you doing? Yeah, write down, children. Write the note and then take down the question. Got it? Finish writing this? Done writing, online children?
Yes, ma'am.
Okay. Now let's answer these questions. A, pi by 2. See, which of these, the heading is, which of these are rational numbers? Which of these are rational numbers? Choose all the correct answers. B and D. Okay. But let's understand all the options. Pi by 2. What is pi by 2? It's a non-terminating, non-repeating decimal divided by 2, which will be another non-terminating, non-repeating decimal. Okay, let me know. You just understand like this. Pi is a non-terminating, non-repeating decimal. If you divide that by 2, you will get a new non-terminating, non-repeating decimal. And hence it's an irrational number. 0.14 recurring. Non-terminating, repeating decimal, rational number. So the numerator is a non-terminating, non-repeating decimal. Numerator is a non-terminating, non-repeating decimal. With irrational number.
Because
It's an integer. It's an integer and also it's minus 76 by 1, P by Q. So write everything. You must not write B and D and. Yeah, non-recurring, non-repeating. Okay, done.
no, ma'am.
Okay. Yeah. Yeah. Finally completed? No, open பண்ணி கொடுன்றா. டைட்டா இருக்கு, ஓபன் பண்ணி கொடுன்றா. Okay, next one. Yeah. Yes, Srijit, tell me. Square root of 21 is a rational number. True or false? Srijit. Sahasra. True or false, the first one? Dhanvir? False. Online children, second one? A is true. 1 minute. Let's clarify his doubt. Yes. Second one, online children, minus 21 is a rational number.
True.
Dhanvin,
True, ma'am.
okay. Next one, 10 pi.
True.
10 pi.
True.
True. Because pi is irrational. Pi into 10 is irrational. Because pi is a non-terminating, non-repeating decimal. If you multiply that by 10, you will get a new non-terminating, non-repeating decimal. Just the decimal point will shift, that's all. Yeah. Okay. What about this one? What about 3 pi by minus 7 pi? Rational or irrational? Parts. 3 pi by minus 7 pi. Rational or irrational?
Irrational.
Asking you the answer. Rational. 3 pi by minus 7 pi is rational. Can anyone say why? Correct. Because you can simplify. Pi and pi will get cancelled. It's minus 3 by 7. Rational. Very good. Akshita. Akshita. What? Minus 3 by minus 7. Very good, Akshita. So just because there is pi, you should not say, you only said if you see pi, say it is irrational. No. In this case, 3 pi by minus 7 pi. Pi and pi gets cancelled. So it is minus 3 by 7. Rational number. Rational number. Because you cannot divide now. Supposing I say there are 10 chocolates. I can't say divide it among minus 7 students. No. Denominator says how many by like the denominator says how many like people or among how many people you're dividing the numerator. If I say 10 chocolates by 5 people or 5 children, so you're dividing 10 chocolates among 5 children. But if I say divide 10 chocolates among minus 5 children, doesn't make sense, right? So the denominator cannot be negative. If the denominator is negative, you can take it to the numerator. What about the last one? Last one?
Ma'am, false, ma'am.
Why? Srijit, see, terminating decimal, no? The sum of these two numbers, it's a terminating decimal, so it's a rational number.
Yes, ma'am.
Yeah, write down the statement and then say true or false. Don't just write true, false, true, false. Yeah, yeah, correct. Where do you write what? I've not written reason anywhere, no? Nothing. I said write the statement also, I said. Make a note of the question. 3 pi by minus 7 pi is 3 by 7. and it's rational. See, you didn't note that? Note. Okay, next one. Give any three examples of irrational numbers that are radicals.
Ma'am, 1 minute, show the previous slide. Ma'am.
Correct. You want to say Harani? Look, ஏதோ ஒரு நம்பர் சொல்லி அது அப்புறம் ஃபோர்த் பவர் இருந்துச்சுன்னா வேண்டாம். Take smaller numbers.
Finished, ma'am.
Oh, okay. Yeah, question also. What about fifth root of 32? Is it irrational? I'm asking. Yeah. Fifth root of 32 is not irrational because 2 multiplied with itself 5 times is equal to 32. That's what I'm saying. Okay, so fifth root of 32. Then that sign, square root, cube root, that's with that sign, you should write the example. Pi by 2. No, pi by 2 is not radical. Sign should be there. Yeah. The symbol, square root symbol, cube root symbol. You should use that and write an example. Square root of 10. Okay, 10 and then what? Okay. No. There's nothing like this. Tens, if you write square root, you must write square root of what? There should be a number there. Simply square root has no meaning. The sign alone, this is the radical sign. Square root of what? You should write something here. 10 square root has no meaning. See, maybe sometimes when you mispronounce, when you mispronounce this as 10 square root. So you feel 10 square root like this. That's because we don't pronounce it correctly. 5 square root, 3 square root. So we feel 3. So that means we are mispronouncing. This one is not 3. This is square root of, this is square root of, the symbol stands for square root of 3. Yeah, there should be a number, yes. Which section? A, B, G. Completed, children?
Yes, ma'am.
Okay. Yes. Sahasra, tell me the answer for the first one. Square root of 16 is a rational number.
False. False, ma'am.
No, square root of 16 is 4, no?
Oh.
And what is 4? 4 is 4 by 1. Integer by integer, rational number. True.
Yes.
Next one, Sahasra, minus 5.
Yes, ma'am. True.
Yeah. Next one. Is 0 a rational number? Give a reason for your answer.
0 is not a rational number, ma'am.
Okay. The answer for the second one is 0 is a rational number. 0 is a rational number. Because it has a P by Q form. 0 can be written as 0 by 1 or 0 by 2 or 0 by 50 or 0 by 100. Yeah, because 0 divided by 1 is 0 only, no? 0 by 2 is 0. 0 by 50 is 0. 0 by 100 is 0. You can write 0 with any denominator. So that, and 0 is an integer. 0 is an integer. You can see integer by integer. See it, integer by integer. 0 is an integer, 2 is an integer. 0 is an integer, 50 is an integer. Integer by integer is a rational number. Is 0 a rational number? Yes, 0 is a rational number. Yes. 0 is a rational number. 0 can be written as 0 by 1, 0 by 2, 0 by 50, 0 by minus 7. This includes 0 can be written in the P by Q form. In the P by Q form as, or I'll just write it again. 0 can be written in the P by Q form as. Just write the same thing again. You don't erase anything. Yes, 0 is a rational number. 0 can be written in the P by Q form. Navneet?
I get them. 96 marks itself. I'm told people from 300 but you can start making the question. Now I send you the portions.
Ma'am,
Yeah, completed?
ma'am, no, ma'am. I was left at the meeting because of the network connection, ma'am.
Okay.
Can you show the previous lesson?
Previous slide, huh?
Yes, ma'am. Ma'am, I left from true or false, ma'am. Second question. Yes, ma'am. This one I wrote, ma'am.
This is the next
Yeah,
one.
this
Take
one,
a screenshot and complete it. Take a
Okay.
picture.
Let me take.
Taken?
Yes, ma'am.
Yeah, then this.
Ma'am, this I want to take a screenshot.
Yeah, because yes, we are now in the third one.
Okay. Taken, ma'am.
Okay. Write any 3 examples of irrational numbers that are decimals. Yeah, Sahasra, tell me. Sahasra, Danvin. Yeah, tell me. Repeat loudly. Correct. Yeah. Zero point. Should write only decimals. Irrational numbers that are decimals, not radicals, that are decimals. Hmm. Correct. If they ask decimals, you should not write radicals. If they ask radicals, you should not write decimals. If they simply say give examples of irrational numbers, then you can write anything. Yeah.
6, 8, 9, 7, 4, 0, 8, 7.
Enough. You can give, see, you can also give, try to give examples like, 223, 224, 225, and so on like this. Or you can write, stop. No, that's it, that's it. Okay. So non-terminating, non-repeating decimals are irrational numbers. Yeah. Somebody's mic is enabled. Please disable your mic. Srijit, please disable your mic. Srijit, kindly disable your mic. Yeah. This will be your homework. Children, I shared this image. This is your homework. What's up?
We discuss and group and ourselves and tell you question. You can see which is the correct answer.
All right. There's the next question. Write all integers between -5 and 5. Write all integers between -5 and 5. The number line is just for you to understand. Finished? Okay. That's it. With this, I'll finish rational numbers. I just have to explain one more concept. Inserting rational numbers between two given rational numbers. Okay. So in session 1, we did take up some statements and understand, if there are natural numbers between two natural numbers, if there are whole numbers between two whole numbers, if there are integers between two integers. Okay, we understood all that. So now, between two rational numbers, there are infinitely many rational numbers. There are infinitely many rational numbers between any two given rational numbers. Is this statement true? Okay. Is there any natural number between two consecutive natural numbers? Is there any natural number between two consecutive natural numbers? Between two consecutive natural numbers, there is no natural number. But between two natural numbers, yeah, there are natural numbers. Between two consecutive natural numbers, there is no natural number. But between two natural numbers, there are many natural numbers. There can be many natural numbers. It's not a natural number. Similarly, between two integers, between two consecutive integers, say -3 and -4, between two consecutive integers, there is no integer. There is no integer between two consecutive integers. But between two integers, like if we had the question now, no? Between these two integers, -5 and 5, they are not consecutive integers. -5 and 5 are not consecutive integers. Now, between these integers, between the integers -5 and 5, yes, there are some integers, right? But it's countable, that's all. These are the only 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the only 9 integers between -5 and 5. So that means what? Between two natural numbers or between two integers, you will have countable number of integers or countable number of natural numbers. Okay, but between two rational numbers, there lies infinitely many rational numbers. Between two rational numbers, there lies infinitely many rational numbers. Now we are going to learn how to insert rational numbers between two given rationals using the equivalent number method and the mean method. Stop it. Yes. Okay, so we have two methods, the equivalent number method and the mean method. Okay, using these two methods, you can insert rational numbers between two given rational numbers. -6/7 and -4/8. Let me take another example. Both are the same. Okay. So find three rational numbers between -3/5 and -1/2 using both the methods. Using both the methods. Both the methods meaning? Yeah, using write the question. You can write no. Yeah. Equivalent. Yeah. Now is there space between the numerators -5 and -6? There's no space no between -5 and -6. There's no space. Equivalent number method is you understand this, right? It's not new. So the denominator is 5 and 2, LCM is 10. So write the fraction equivalent to -3/5 with denominator 10. No, see this part is easy or no? Correct. Yeah. So basically you'll have to bring both the numbers to the same denominator using the LCM. Bring both the numbers, both the fractions to the same denominator using LCM. So -3/5 is nothing but -6/10. -1/2 is -5/10. But look at the space between the numbers in the numerator, -5, -6. Yeah. So there is no space between the numbers in the numerator. So what do? You further multiply. If you have to insert three numbers, you should multiply at least by 4. Or you can multiply by any number greater than 4. See, you want to insert three numbers, right? What are the numbers you have now? -6/10 and -5/10. You see that there's no space between -5 and -6. So you want to expand that space. You want to insert three numbers, right? So you multiply at least by 4, the number 4, or anything more than that. You can use a large number like 10 also. Simply use, or you can use 100. You can insert, yeah. So what you do? Multiply the numerator and denominator by 10 again. By 10 again. So it will be -60/100. And here also -50/100. Now see the space between the numerators has increased. -50, -60. Now -51/100, -52/100, minus 53 by 100, minus 54 by 100, so on till minus 59 by 100 are some rational numbers between these two rationals.
Ma'am?
Yes?
Ma'am, can you show the third sum, ma'am?
This one?
No, ma'am,
Oh. Third sum in the earlier presentation, was it?
Yes, ma'am.
Second. This one?
No, ma'am. In that block 2 lesson 1 in class practice questions.
Which one?
No, ma'am.
No, you have not missed anything.
No, ma'am, that
Okay, maybe after the class you can just stay back and ask me. I'll show you all the slides.
okay, ma'am.
Okay, I'll just try once more. See, this is the first presentation I used. I'll come from the beginning. Tell me. Yeah, from here.
Ma'am, this one I finished. This one, U20. Yeah. This one, ma'am. Yeah, ma'am.
That
The
this third
question.
one.
Okay, ma'am.
Correct?
Yes, ma'am.
Okay. Done?
I'm doing.
No, meaning you take a screenshot.
Yes, ma'am. Yes, ma'am. Second, ma'am.
Okay. One minute. So, under the equivalent number method, you will have to bring both the fractions to the same denominator using LCM. Okay. So when you do that, you get minus 6 by 10 and you get minus 6 by 10 and minus 5 by 10. But there is no space in the, there's no space between the numbers in the numerator, minus 5, minus 6. So you want to expand the space. So further you multiply the fractions by 10, 100, whatever. You just want to expand the space in the numerator. So I have multiplied both the numerator and the denominator by 10 in both the numbers. The denominator should not change. They should have the same denominator. Any denominator, but same denominator. If the denominator changes, then it's difficult to insert. Okay, so first you bring them to the same denominator using LCM. After that, you should maintain the same denominator, meaning if you multiply this one by 10, the next one also you should multiply by 10. If you use 15 here, then the denominator will become 150 here and 100 here. Then you cannot insert. So you get minus 60 by 100 and minus 50 by 100. So three numbers between them are minus 53 by 100, minus 57 by 100, minus 59 by 100. Oh. So minus 51 by 100, minus 53 by 100. Yeah, okay. Minus 57 by 100. are three rational numbers between -3/5 and -1/2. Yeah. Drink water. Any three.
We can write 1/100. It should not be in order.
You write in the order, but you need not write the numbers that come one after the other or something. Like -51, then I've written -53, then -57. Between -50 and -60, it should be. Anything, yes. Any number between -50 and -60. So this is the disable your mic, Srijit. This is the equivalent number method. We'll answer the same question using the mean method.
Can you show the previous slide?
Yeah. Look at the board of Anirudh.
Yes, ma'am.
Okay. Okay. So for this, just add the numbers and divide by 2. That's all. That's the mean method. Add the numbers and divide by 2. Now add these two numbers. -3/5 plus -1/2. Add the two numbers and divide by 2. Okay, so one number, see the numbers are -3/5 and -1/2. A number meaning a rational number. A rational number. Okay, let me write a rational number. A rational number between -3/5 and -1/2 is add the two numbers and divide by 2. Okay, so that's equal to -3/5 -1/2 because plus into minus is minus. Plus into minus, minus divided by 2. What is divided by 2? It becomes into 1/2. Divided by 2 becomes into 1/2. Now take the LCM. Division becomes multiplication and reciprocal of 2 is 1/2. Now the LCM of 5 and 2 is 10. So it will be -6 minus 5 into 1/2. LCM. So -11/10 into 1/2. So it's -11/20. Yeah. This is the mean method to insert rational numbers between two given rational numbers. Add the two numbers, divide by 2. That's all. They'll say half of A plus B. Did they say that? Half of a number is nothing but dividing the number by 2. That's what averages mean only. Average method is the mean method. This is the idea. Add the two numbers, divide by 2. That's all. This is add the two numbers, divide by 2. See, for example, if you have to insert rational numbers between 3 and 4, between 3 and 4, between 3 and 4 rational numbers. Okay, so 3 plus 4 by 2, 7 by 2, 3.5. Now, so if 3, so 3, 3.54, correct? Now take any two numbers, 3 and 3.5, add and divide by 2. So 6.5 by 2. What is 6.5 by 2? 3.25. So now what is it? 3, 3.25, 3.5, 4. Take any two numbers. Take any two numbers. So 3.5 and 4 by 2. Add and divide by 2. So 7.5 by 2, which is 3.75. So it is 3, 3.25, 3.5, 3.75, 4. Now again, you can add two numbers and divide by 2. That's the idea. That's how we insert. Division, you do the long division and find the decimal value. No. It's just, I'm just telling you that it's only adding and, okay, 1 minute. It's just adding the two numbers and dividing by 2. That's all it is. Here, because it is fractions, we have to take the LCM. Otherwise, see you. Okay, let me give that as another question. We'll finish this. We'll take that as another question. Is this understood? Okay. So now where are we? Between, you can just write this. So between minus 3 by 5, we have inserted minus 11 by 20. And what is that? Minus 1 by 2. Correct? No, you're still confused, right? No, 1 minute. Let me do it again. 1 minute. You tell me, I'll do it. What are the two numbers? Minus 3 by 5 and minus 1 by 2, right? See here, this is the mean method. You should start like this. A rational number between minus 3 by 5 and minus 1 by 2. Minus 3 by 5 and minus 1 by 2 is, okay. Add the two numbers. Add the two numbers. So it will be minus 3 by 5 plus minus 1 by 2. And divide this by 2. Add these two numbers and divide the result by 2. Okay. So what is this equal to? Minus 3 by 5. Plus into minus is minus. So minus 1 by 2 divided by 2 becomes into 1 by 2. Because division converts to multiplication. Reciprocal of 2 is 1 by 2. Next step, take the LCM. 10 is the LCM. So it will be minus 6, minus 5 into 1 by 2. LCM. LCM, no, because this is 5, so we should multiply by 2, right? And this is 2, so we should multiply by 5. So it will become minus 6 minus 5. So that's minus 11 by 10 into 1 by 2, which is minus 11 by 20. So now we have inserted one number. So now we have minus 3 by 5, minus 11 by 20, and minus 1 by 2. We have inserted minus 7 by 20 between minus 3 by 5 and minus 1 by 2. Now take any two numbers. Don't take the same two numbers which you've already taken. Take two numbers now. Which two numbers you want to take? Minus 3 by 5, minus 11 by 20. Right. A rational number between which one? Minus 3 by 5 and minus 7 by 20. Minus 3 by 5 and minus 11 by 20 is, add the two numbers, 5 plus divided by 2. Take any two numbers. You can take these two also if you want. Take any two numbers and divide by 2. So this is nothing but minus 3 by 5 plus into minus 11 by 20 into 1 by 2. What's the LCM? 20. So this 5 into 4 is 20 into 4. 20 into 1. Minus 12 minus 11 into 1 by 2. Minus 23 by 20 into 1 by 2. Minus 23 by 40. Okay. Now, where is this? It's between minus 3 by 5 and minus 11 by 20. So what is it? Minus 3 by 5, minus 23 by 40, minus 11 by 20, and minus 1 by 2. Minus? Yeah, because same signs, no, should add and put the same sign. Same signs, add and put the same sign. Which one? Yes, yes, yes. Huh?
The
Previous one you should? This one, huh? Okay. A rational number between and it's 43 by 1 8. Which two numbers you considered? Which two numbers you considered? And minus? Minus 23 by 40. And minus 1 by 2. Finished? Till here you finished? Okay, now tell me, we'll take the last two numbers, minus 11 by 20 and minus 1 by 2. So what should you write? A rational number between is division becomes multiplication and reciprocal. Yeah, what's LCM? 40, sorry, 20 itself. 20. So it will be into 1. Minus 11. Minus into 10.
Minus 10. Minus 10. Into 1 by minus 21 by 20 into 1 by 2 we get minus 21 by 40.
So it's minus 3 by 5. Minus 23 by 40. Minus 11 by 20. Minus 21 by 40. Minus 1 by 2. So these are the three numbers you've inserted. You've inserted these three numbers. You can keep finding like this. You can take any two numbers. Minus 23 by 40. Just write the result here, meaning the last step here. Minus 23 by 40, minus 11 by 20, and minus 21 by 40 are three rational numbers between minus 3 by 5 and minus 1 by 2. Finish it by yourself. Very good. Sorry? Two numbers using the mean method. You should find it fast. Finished? Srijit, Sahasra, and Dhanvin?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, we'll just take a simple one and wind up the session for today. Now see this. One second. Find three rational numbers between say 9 and 10 by the mean method or using the mean method. No, we'll finish it now together. Yeah. Find three rational numbers between 9 and 10 using the mean method. So how do you do this? One number or a rational number between 9 and 10 is 9 plus 10 divided by 2. 19 divided by 2. Same, I see there it was fraction, so you had to take the LCM. Here you can directly add. No LCM. What is Add and divide by 2. 2 is not the LCM. What is 19 by 2? 9.5. So between 9 and 10, you have inserted 9.5, correct? Between 9 and 10, you have inserted 9.5. Now take 9 and 9.5. A rational number between 9 and 9.5 is, add the two numbers. Add the, 9 plus 9.5. Add the two numbers and divide by 2. What will you get? 18.5 divided by 2. Divide. You divide 18.5 by 2. What will you get? 9.25. 9.25. Do the long division, you get 9.25. Now, between 9 and 9.5, you have inserted 9.25. One more number we have to find. Yeah. A rational number between, what do you want to take now? 9.5 and 10? .5 and 10? Okay, between 9.5 and 10 is 9.5 plus 10. Add the two numbers and divide by 2. So that is 19.5 divided by 2, which is 9s are 18. 1 remains. 5 comes down. 7s are 14. 1 remains 5. 9.75. So 9, 9.25, 9.5, 9.75 and 10. So these are three numbers you've inserted. So 9.25, 9.5 and 9.75 are the three rational numbers between 9 and 10. Are three rational numbers between 9 and 10. So mean method is simply adding the two numbers and dividing by 2. Hey, excuse me, I don't understand that. Completed online, children?
Yes, ma'am.
Okay. Since it's time, if you've not finished, others, please take a screenshot. Okay. So, all right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night.
Finished, ma'am. Thank you, ma'am.
Thank you. Good night.